So in this video, I want to introduce you to the terminology of kinematics. So by that I mean talking about distance and displacement, about speed and velocity, and about acceleration. What are these things and how do they link and how are they measured? So hopefully I could do that all in one video before we go on and look at some examples. So at the top of the tree is displacement. Now, essentially what you need to be thinking about is the problems that we deal with at GCSE level are one-dimensional problems where you will have a particle or a person walking from one direction to another, okay, along a line. So you can kind of imagine that this is a road and there is a person, let's say, at the origin, and the person can walk to the right or they can walk to the left, okay? And what we're going to do is we're going to take to the right as a positive direction and to the left as a negative direction, okay? So displacement tells you where you are in relation to where you've come from. Okay, so if you start at the origin and you are now at a position of 5 meters, you have travelled positive 5 meters. Your displacement is positive 5 meters. Alternatively, you could have walked 5 meters to the left, in which case we would write it as minus 5 meters. Okay, so your displacement can also be negative. Minus 5 meters tells me that I am 5 meters to the left. Okay, so it gives me this idea of a position along this line. Okay, whereas the word distance infers there's no direction attributed to it. Okay, so distance is talking about, well, how far away are you from where you started? So it's not an instruction of like where you are, it's an instruction of how far away you are. So they're very closely linked. So if I was here, then you would say I've travelled 5 meters. So my distance is 5 meters. If I was here, you would say I have travelled 5 meters. So my distance is 5 meters. So you can see that the displacement can be positive or negative. The distance can only ever be a positive value, okay? Or 0, if you like, okay? So displacement, the magnitude, the word that we use as the magnitude of displacement is distance. So the magnitude of displacement is distance. Okay? Right, so we have displacement. Then we have the next level down, velocity. Okay, now velocity tells you how far you have gone. I'm choosing my words carefully, in a certain amount of time. Now that's not quite right because I've used the term in, we're talking about speed there, okay? So speed is telling you how far you've gone in a certain amount of time, okay? So velocity is the link with displacement. So velocity infers that there is some direction occurring. So a velocity could say that I am travelling at 5 meters per second, or it could be minus 5 meters per second. This would be saying that I am travelling 5 meters per second in the positive direction, whereas minus 5 meters per second would be saying I'm travelling 5 meters per second in the negative direction. Okay? And so there is a signage here attributing which direction you are travelling. So the notation here, meters seconds to the -1. There are many different ways of writing this. You may see this, okay, meters over seconds like that. But the idea here is that it's inferring that you've got meters over seconds. So essentially when we're talking about this, you're talking about meters over seconds, or displacement over time. Now, when we get on to displacement time graphs, what we're going to be looking at is time in the horizontal direction and displacement as the vertical. So, if you had a line, and this is talking about the displacement at a certain amounts of time, okay? So this would be somebody walking at a steady speed in the positive direction. Then what you could do is you could work out the gradient of this line by doing the difference in the y coordinates divided by the difference in the x coordinates. Well, this would be a change in displacement over a change in time. Displacement divided by time. Displacement divided by time. So the gradient that you get here is meters per second, and that is your velocity. So the gradient of a displacement time graph gives you your velocity. Now, if I'm saying that I'm travelling 5 meters per second in this direction, that's my velocity, or 5 meters per second in that direction, so I've got -5 in that case, then you would be saying that my speed is 5 meters per second, 5 meters per second. So the speed, just like distance, ignores the plus or minus at the front, okay, and is looking at the magnitude of velocity. So the magnitude of velocity we refer to as speed. And of course, speed is distance over time. So much the same way as velocity is displacement over time. So let's make this as clear as possible. So velocity is displacement over time, whereas speed is equal to distance over time. Okay, both of them are measured in meters per second. So displacement and distance are both measured in meters. Velocity and speed both measured in meters per second. Okay, so then we talk about acceleration. Okay, now acceleration is units wise something like 5 meters per second per second. Okay, now this one can be tricky. 5 meters per second acceleration is telling you the rate at which velocity is changing. So accelerating, as your kind of understanding, would be, oh, I'm getting faster, or I'm getting slower. Okay, so if my acceleration was 5 meters per second, I am getting faster in the positive direction at 5 meters per second. Okay, that's what you can infer by that. Now, I'm going to introduce the negative. So let's say minus 5 meters per second. Okay, so 5 meters per second, accelerating in the positive direction. Minus 5 meters per second, accelerating in the negative direction. Okay? However, there's always a sting in the tail, isn't there? Right? However, there is one other thing here. Right? They have alternative meanings. Because velocity can be positive or negative, it's telling you the direction in which you are travelling. The acceleration is telling you whether you are speeding up or you are slowing down. So 5 meters per second, positive, can mean accelerating in the positive direction. Minus 5 meters per second can mean you are slowing down in the positive direction. Okay? So we have speeding up in the positive direction, slowing down in the positive direction. But I said that minus 5 meters per second meant speeding up in the negative direction. Okay? So if that means speeding up in the negative direction, that means slowing down in the negative direction. So the direction is quite convoluted, right? It's quite a difficult thing to get your head around. It's more looked at and developed when you get to A level. There is this kind of like bridging bit at the moment where this is stuff that at A level you look at in more detail and you look at harder problems to deal with it. Okay? But I think it's important that you kind of like get that idea now. Notation wise, meters per second. Well, what does that mean? Well, the thing with meters per second, this is meters per second, okay? So when you are working with your indices, if you multiply s to the minus 1 by s to the minus 1, you get s to the minus 2. So these two things are the same. So meters per second is the same as dividing meters per second by seconds. Now meters per second is a velocity over seconds, which is time. So acceleration is velocity over time, or change of velocity over time. So acceleration is change in velocity over time, and is measured in meters per second. Now you might be wondering, is there a word for the magnitude of the acceleration? We just refer to it as the magnitude of acceleration. Okay, it doesn't have its own fancy word there. Okay, right. So, thinking about velocity time graphs, then, which is another thing that we're going to be moving on to. Then, if you had a graph that looks something like this, so this would be saying that as time goes on, we're starting at zero velocity, so starting at stationary, okay, so stop still, and then you are progressively getting faster. If you were to look at the gradient of this line, this would be a change in velocity divided by a change in time. A change in velocity divided by a change in time. So the gradient is equal to the acceleration. So when you're looking with a velocity time graph, the acceleration can be found by working out the gradient. Now, if I just remove that bit, let's say you're actually looking at an area, so the area between the line and the time axis. Now, of course, you'd be looking at the area of a triangle here. So think about area just in its most base terms as one side multiplied by another. Okay? If you were to multiply this length by this length, you are multiplying a change in velocity by a change in time. Okay, so if you're multiplying two things together as an area, you're doing a velocity times a time, okay, to find an area. I know there'll be a half in there because it's a triangle, but just think of it as the base terms. When you work out an area, you're doing really one side multiplied by another. Velocity is meters per second. Time is in seconds. So when you multiply meters per second by seconds, imagine s to the 1 there. Using your indices knowledge, if you multiply those two things together, the indices add, -1 plus 1 is 0. So you get this, and s to the 0 is just 1. So you just get left with meters. So the area has units of meters, which is your displacement. So you can work out the displacement from a velocity time graph by looking at the area between the line and the time axis. So velocity time graphs have two key features. Gradients mean acceleration. Areas find you displacement. Okay, so they're particularly useful and ones that kind of get talked about a lot and used a lot because you can get so much from them. Okay, velocity time graphs. Can you have an acceleration time graph? Yes, yes you can. Interpreting them can be a little bit fiddly. So if you have acceleration and then time, let's say we have lines something like that, then as we start off, okay, the acceleration is 0, but we're getting faster and faster and faster as the acceleration increases. Okay, so you're going from a constant speed and getting faster. Now, if you were to work out the gradient of that line, okay, then you would be looking at acceleration over time. Okay, so you'd be looking at meters per second, per second, per second. So if you're interested, feel free to look up what that is. Okay, if you were to look at the area, so what I'm trying to hinting at there is that there's a whole kind of like other level here, so downwards, right, and in actual fact upwards as well, okay, of measurements to do with this. So I would definitely Google them so you can just see what they're called even, right? So have a look at that. But that's kind of, I'm not going to go into actually what they are and how to interpret them. So you could look at the gradient, you could look at the area. The area would be an acceleration, change in acceleration over time. So as an area, you would be multiplying meters per second by seconds. This would give you meters per second. -2 plus 1 is -1. And because you get meters per second, the area there must be velocity. Okay? So, there's a whole kind of linkage here between these three key concepts in kinematics: displacement, velocity, and acceleration. And I've gone through a lot of these kind of concepts quite quickly, but I wanted to kind of like bring them all together. How well you kind of like know this in their linkage really comes down to the types of questions that you have to deal with. Okay, as I said, we're really kind of like at the kind of like edge of A-level maths here. So as we go through the questions, as we go through these videos, you'll be able to see what these kind of different linkages are, particularly looking at displacement time and velocity time, or distance time graphs and speed time graphs. Okay, acceleration time graphs are going to be a bit beyond where we're at the moment, but really your main focus should be making sure you understand displacement and velocity with distance and speed as their magnitudes.